Let's try another example here. So we've got a long tube. It's got a length of 300 meters. Woo! And it's filled with air at a temperature of 320 Kelvin. We have a sound wave, a yell on one side. We're going to ask ourselves, well, how long will it take to reach the other side? And we're going to do the same thing with helium at that same temperature. So let's try it out. So for both of these, I just need to figure out what the speed of sound is, and then figure out how long it would take that speed of sound to travel 300 meters. So for air, gamma RT. I have a temperature, I have a specific gas constant, I know what the ratio of specific heats is. And for helium, I have the same thing, just different ratio of specific heats and different specific gas constant. It might surprise you that their speed of sound is so incredibly different, but the difference in the speed of sound is the reason that your voice sounds so crazy when you inhale helium and then try to speak through it. It does things to you. Okay, but that being said, I have the speed of sound for both helium and for air right now. Now let's use some basic physics. So we can figure out that distance you travel is equal to your velocity times time if you have a constant velocity. And so I can rearrange that to figure out the time it takes. So for air, it's simply equal to the distance traveled, which is just the length of the tube, over the speed of sound of air. So it would take it 0.837 seconds. Helium is much faster, so it only takes it 0.285 seconds. Now, coming back to this again, I might not have given you a good enough answer for this one, but another reason that helium is so much faster than air is because helium is lighter than air, okay? It's lighter and therefore it can move faster than air on average. Air is much heavier because it's made up of, oxygen, which has a molecular weight of 32, and it's made up of nitrogen, molecular weight of 28, made up of water, which has a molecular weight of 18, okay? While helium is just 2. So much heavier molecules, and therefore they're moving a lot slower than the helium is. Okay, that should be it for this time. I already answered that question. I always get ahead of myself. Thanks for paying attention. I'll see you all later. Bye-bye.